Module 2 lecture 1 we discuss about the coal and coal as a chemical feedstock and what are the various technology available for the production of the chemical from the coal root. In the lecture 2 we will be discussing about the coal carbonization, the process that being used in coke oven plant, and in detail about the coke oven plant, how the coke is produced, what are the various chemicals we are recovering. We will start with the introduction part first before starting about the coke oven plant. Due to the development of iron and steel industry, coke oven plant has become an integral part of iron and steel industry, because you see the huge amount of the coal in the form of the coke that we are using in the steel industry, and the steel industry, as I told you in the lecture 1, that the second largest user of the coal. Due to the increasing demand of the iron and steel, there has been a considerable increase in the coke oven capacity, which resulted in increased output of the coal chemicals through the coke oven plant. Coal manufacturing technology: coal making through byproduct recovery, coke making through non-recovery and heat recovery. In India, building of coke oven batteries was initiated in the beginning of the 19th century. Now about 3,000 ovens are in operation construction in the coke oven plant. By the year 2011-12, the world coking coal requirement will be about 433 million metric tons, in which India's requirement is estimated to about 54 million tons. This is a huge amount of the coke that is being required, because you see the iron and steel industry, they are developing, the consumption of the coke that is increasing. Byproduct from the coal gasification includes coke, coal, tar, sulphur, ammonia. Coke is the major product, but coal tar, sulphur and ammonia, these are the byproducts from the coke oven plant. Coal tar distillation, which is also very important part of the coke oven plant, produces tar, benzol, cresol, phenol and cruciate. Blast furnace require coke for uniform size, high mechanical strength and porosity with minimum volatile matter and minimum ash. This is the requirement, and this is why there is differentiation in the metallurgical grade coal and non-metallurgical grade coal. Coking coal may be divided on the basis of their coking properties: prime coking coal, medium coking coal and semi coking coal. The prime coking coal produces strong metallurgical coke, while coals of other groups yield hard coke. So, our requirement in case of the metallurgical industry is the prime coking coal. Coal carbonization and the coke oven plant. Coal carbonization, which involves heating in the absence of air, because this process of the carbonization that itself we define as the when any substance is heated in the absence of air. So, in case of the coal carbonization, which involves heating in the absence of air, produces a variety of solid, liquids and gaseous products, and these products are very important from the chemical point of view. Carbonization can be carried out at low temperature or the high temperature, and depending upon the type of the carbonization and the temperature, the yield of the product that vary. Low temperature carbonization is used to produce liquid fuel, whereas the high temperature carbonization is used to produce gaseous product. Various products from the coal carbonization in addition to coke are light aromatics, that is the benzene, toluene, xylenes. These were the earlier source of the aromatics before coming of the petroleum refinery. Now we are making the aromatics from the catalytic reforming process, tar acid, tar bases or pitch. This is actually the potential availability of the selected chemicals from byproducts of high temperature carbonization, where you are finding the various aromatics: benzene, toluene, xylenes, naphthalenes, methyl naphthalenes, phenol, cresol, diphenyl oxide. These are present in case of the coal, although the amount is less. gas spirit are the white spirit, phenols, cresols and xylenols, medium boiling phenols. Coke oven batteries. Now we will discuss about the coke oven batteries and what are the process involved in case of the coke oven plant. Coke oven are used to convert coal into coke by carbonization of the coal in absence of air and thereby distilling the volatile matter out of the coal. Coke is taken as product which is used as a fuel and as a reducing agent in smelting iron ore in a blast furnace, and coke oven gas as byproduct is treated for recovery of the coal chemicals. The coke oven temperature is kept as high as 2000 degrees centigrade. Crushing and screening of the coke is done to obtain the suitable size of the coke for use in the blast furnace. Coals needs to be stored at various stages of the preparation process and conveyed around the coal preparation section. Crushing and screening are the important part of the coal handling plant. Crushing reduces the overall size of the coal so that it can be more easily processed and handled during the carbonization process. Screens are used to ranges the size of the coal. Screens can be static or mechanically vibrated. Dewatering screens are used to remove the water from the product. Coke oven plant consists of the coke oven batteries containing number of ovens, around 65 ovens in each battery. The coal is charged to the coke oven through the charging holes. The coal is then carbonized for 17 to 18 hours, during which volatile matter of the coal distill out as a coke oven gas and is sent to the recovery section for recovery of the valuable chemicals. The ovens are maintained under positive pressure by maintaining high hydraulic main pressure of 7 mm water column in the battery. The cooking is complete when the central temperature in the oven is around 950 to 1000 degrees centigrade. At this point the oven is isolated from the hydraulic means, and after proper venting of the residual gases the doors are open for coke pushing. At the end of the cooking period, the coke mass has a high volume shrinkage which leads to the detachment of the mass from the walls, ensuring easy pushing. The coke is then quenched and transferred to the coke sorting plant. This in brief about the various stages that is involved in making of the coal. Some of the operating parameters are very important. The control of the oven pressure is quite important because of the lower pressure leads to air entry while the higher pressure leads to the excessive gassing, leakage of the doors, standpipe, etc. Proper leveling of the coal is important and care is taken so that the free board space is maintained to avoid choking. Coke oven plants are integral part of the steel plant to produce coke, which is used as a fuel in the blast furnace. Coke oven plant produces some of the byproducts. Already we have discussed these products. These are the various sections in case of a coke oven plant. That is the first, as I told you earlier, the coal handling plant and the coal preparation plant. To prepare coal blend suitable for carbonization, various steps involved are unloading and storage of the coal, blending of the coal of the various grades, coal crushing and transportation to the coal storage tower. Partial briquetting to prepare briquette of the coal to charge along with the coal into the coke oven. Coke oven batteries to convert coal into coke by carbonizing coal in absence of air. The process steps involved are coal charging and coal carbonization. Coke sorting plant, crushing and sorting of the coke to suitable sizes for using the blast furnace. The steps involved are coking, coke pushing, coke quenching, coke crushing and screening. Coke oven gas recovery, because this is one of the very important operation in case of the coke oven plant. Collection and cleaning of the coke oven gas and recovery of the byproduct. This involves gas cooling, tar recovery, desulfiration of the coke oven gas, recovery of the ammonia, recovery of the light oil. Ammonia recovery and ammonium sulphate production. Recovery of the ammonia and neutralization of the sulfuric acid or nitric acid in case of the ammonium nitrate. or calcium ammonium nitrate, because in earlier we were making in this Rourkela steel plant ammonium nitrate, and that was again it was they started making calcium ammonium nitrate. As you know, the ammonium nitrate, that is also one of the explosive, but ammonium sulphate in Vilai steel plant we are making ammonium sulphate, and all the steel plant they are having the ammonium sulphate or the ammonium nitrate plant. Wastewater treatment, that is the treatment of the phenolic waste, because the coke oven plant is one of the major source of the phenols, and the treatment of the wastewater from the coke oven plant, that is very important. Partial briquetting of low grade coal are prepared using a binder up to 2 to 3% of the charge. This partial briquetting of the coal is charged with the coal into coke oven, with significantly improve the quality of the coke. This is the various steps that is involved: coal handling, coal preparation, briquetting, blending of the coal, coal storage, and from the coal storage it is going to the coke oven batteries. Coke oven batteries, one of the requirement in case of the coke oven plant, that is the air, and so air that is going to the coke oven battery, coke screening, blast furnace, nut coke or the coke bleach. These are the some of the different quality of the coke that you are getting from the coke oven plant. This is the flow diagram of a typical coke oven plant, that the coal after various the pre-treatment and after briquetting, all those things, that is going to the coke oven batteries, and from the coke oven batteries the coke oven gas that is going for the further processing, and coke that is going to the pure for the blast furnace, and then the coke oven gas, it is going to the gas collection system, separation of the flushing liquids, and then the flushing liquid here actually the ammonia liquor that we are using as a flushing liquor, which is produced during the process itself, and separation. Then we are going to the coal, we are getting coal tar. This coal tar going to the coal tar distillation product plant. After the coal tar distillation we are getting a number of the aromatic compounds. The gas that is going to the acid catcher, saturator, where we are using sulfuric acid. In case of the ammonium nitrate, that may be the nitric acid. The crushing coke oven battery, in oven heating coke oven gas, byproducts, waste gases, and this is the screen, and then you are getting the different. Already I have discussed this flow diagram. Various products from the coke oven distillation of the benzoyl. These are the products which are getting after the distillation of the benzoyl. Tar products, piscium anthracite oil, naphthalene, road tar, cresolate, sodium phenoate, and dephenolized oil. Ammonia used for the production of the ammonium sulphate, crude benzyl, benzene, toluene, xylene, still bottom, and the solvent oil. Coke oven gas for industrial use as a fuel. Typical analysis of the blast furnace coke which we are getting. Here you see the ash is reduced 15 to 17%, because the ash is very high in case of the Indian coal, and so this is from one typical steel plant that I have taken the data. Volatile metal less than 1, sulfur 0.65, and fixed carbon is 79 to 81%. Coke oven gas produced during the process of coking of coal are used in the coke oven plant for recovery of the various valuable chemicals like tar, ammonia, and the benzol. The high temperature carbonization is used for production of the coal for use in the blast furnace. Various products already we have discussed. These are the products we are getting. Typical yield of some important byproduct: tar 3.2%, ammonium sulphate 1.1%, crude benzol is 0.9%. Gas condensation section: coke oven gas containing water vapors and chemical products of the coking. These are the products from the coke oven plant is cooled to temperature of 80 to 80 to 82 degrees centigrade. During gas cooling, 65 to 70% of the tar is condensed. Further cooling of the gas, the water vapors and the remaining part of the tar get condensed along with some of the ammonia and other chemicals that we discuss in the flow diagram while discussing the coke oven plant, where the ammonia at the scrubbing liquor that we are using. This is the typical analysis of the coke oven gas: methane, hydrogen, hydrocarbons, carbon monoxide, carbon dioxide, oxygen, nitrogen density, and the calorific value. This gas that can be utilized as a fuel. Ammonium sulphate plant. This is the actually the after the gases from the exhaust goes to the electrostatic precipitator where tar is separated, and the tar free gases goes to for the making of the sulfuric acid, where the bubble through the dilute solution of the sulfuric acid in saturators. Ammonia is absorbed by sulfuric acid and ammonium sulphate is formed. If you are interested in case of the if you are interested in ammonium nitrate, then it will be nitric acid in the saturator. 1 ton of the coal adds about 0.3 tons of the tar and 5 to 8 gram of ammonia per cubic meter of the gas. So ammonium nitrate can be produced by using the nitric acid. Benzol recovery, because this is one of the very important part in case of the coke oven plant where we are recovering the aromatics. The gases from the saturator goes to the series of coolers and then to Benzol scrubber, where Benzol is scrubbed with the wash oil. Benzol crude oil goes to the Benzol recovery section, where Benzol is removed and the wash oil after treatment is sent to the scrubber. Crude Benzol thus recovered goes to the Benzol rectification plant. Light crude Benzol contains low boiling sulfur compound, BTX solvent and steel bottom residue. Benzol after washing and utilization with caustic soda is sent to the Benzol column for fractionating into different sections. Various products from the coke oven and distillation of the Benzol. This is the coke which you are getting, of course, from the earth tar, then the ammonia, crude Benzol, that is about 0.85%, that the Benzol, toluene, xylene, steel bottom solvent, that 0.85%. But you see the amount of the coal that we are using for the coking, that is huge, and so this percentage that is actually you are seeing less, but that we are using these the amount, total amount that is used. Coke oven gas for industrial use as a fuel, and this is the moisture content. Coal tar distillation, as I told you, the coal tar after separating from the coke oven gas, the coal tar is produced as a result of high temperature carbonization and is viscous dark brown product with characteristic odor and consists of about 300 different products, and that is why the importance of the coal tar distillation. Some of the major constituents are aromatic, heterocyclic compounds, benzene, toluene, xylene. In the light aromatic, cresol, naphthalene, anthracene, phenanthrene, pyridine, carbazole, picoline is also there. Typical composition of this is a typical composition of the coal tar. There may be variation in the various constituent varying from depending upon the coal quality and the coke oven plant. Naphthalene, phenanthrene, carbazole, anthracene, phenol, cresol and the pyridine compound. This is the content of the which we are getting after the coal tar distillation. Coal tar is reduced as a result of the high temperature carbonization. The coal tar distillation which we are using, that consists of the distillation section, fractional crystallization and washing section, combustible mixture preparation section, phenol rectification section and dolomite tar preparation unit. Extra hard preparation. The tar containing around 5% moisture is first dehydrated before distillation. The dehydrated tar is heated to 375 to 400 degrees centigrade using superheated steam to drive out the flash vapor, and residue is taken as pith. The oil vapor is sent to the anthracene column for anthracene recovery, while the vapor is sent to the other column for recovery of the various fraction, light oil, phenol, naphthalene and the heavy oil fraction. Naphthalene in fraction is sent to the crystallizer to separate naphthalene. As I told you earlier also, the naphthalene, earlier we are making the phthalic anhydride which is being used as a plasticizer. That was the naphthalene route from where we are getting the phthalic anhydride. Now the most of the phthalic anhydride that is we are making, or you can say all the phthalic anhydride that we are making through the orthoxylene route, because the orthoxylene that is produced in the paraxylene plant. Paraxylene is a major raw material for the making of the polyester, and so wherever you are having the this your paraxylene plant, we are producing huge amount of the your orthoxylene, and that is being used for the making of the paraxylene. Phenol is recovered from the various fraction by treating with the sodium hydroxide to form sodium phenolate, which is reacted with CO2 to release the phenol. But still that is, as I told you earlier, that because some of the phenols remain in the water also. The phenol content in the water, that is vary again. So the phenol treatment of the water, that is the reason why the phenolic wastewater we are producing from the coke oven plant, that has to be treated before it is being discharged to the water stream. Pyridine is recovered by washing different fraction with the sulfuric acid. You see, that was the route for the light aromatics and the pyridine. Now we are making the pyridine from the ethylene route, and that ethylene from the ethanol to ethylene, and one of the unit which making the pyridine. And because you see the pyridine is having the wide scope for making the picoline which is being used in manufacture of the especially in the agrichemicals, and the process that is being used in case of the jubilant organisms from, that is from the ethylene route, ethylene to pyridine and pyridine to picoline, that is the. But earlier it was the only route available before coming of these processes. So already I discussed something about the ammonium sulphate, ammonium nitrate. The gases from the exhaust goes to the ESP where tar is separated, and tar free gases go to the dilute sulfuric acid and saturators where we are getting the ammonium sulphate, which is further crystallized, dried, and then it is going for the use as a fertilizer. Cleaner technology in the coke oven plant, because that is quite concern about the environmental problem because of the coke oven plant. Coke oven plants are one of the highly polluting energy. Continuous development has been there to reduce the pollution load and the energy consumption, because these are the two. Energy consumption earlier used to be high. So a lot of the technological development that has taken place, or the cleaner technology that is being implemented to reduce the pollution load from the coke oven plant. These are the some of the cleaner technology, because the concept of the cleaner technology or the greener chemistry came just for the reduction of the pollution load from the, and now the cleaner technology in all the, it is not only the coke oven plant, it may be the paper industry, it may be the fertilizer industry, number of the process that is being developed, and the modification the process that is being done to have the less and less pollution load. So these are the some of the technology that is being used in case of the coke oven plant, that is the modified wet quenching, low environmental impact, coke dry quenching, low emission and energy saving, coal moisture control, fuel saving, because if the moisture is high, that moisture has to be driven out, so that is the will be losing of fuel, so that will incur. If you are having the moisture control, then fuel saving will be there. High pressure ammonia aspiration system for control of the charging emission, modern leak proof doors, minimization of the door leakage, advanced technology for the desulfation of the coke oven plant gas. So this was about the coke oven plant. The lecture 3 of the module 2, that will include about the gasification of the coal, and along with the gasification of the coal we will be also discussing about the gasification of the petrocoke which is being produced from the petroleum industry, because now the huge amount of the petrocoke that we are producing in the refinery because of the use of the heavier crude oil, which is more and more coke formation is there. So that is one of the very important aspects. And third part, in the case of the coal and the gasification, the biomass gasification, because huge amount of the biomass that is available, and now the biomass gasification even along with the coal or the biomass gasification combined, or the this biomass to alcohol technology, that is getting importance, just to have the alternative feedstock, alternative fuel from the, because from the gasification you can produce this in this gas that may be used as a fuel, that may be used as for the production of the large number of the chemicals.